Today we're going to look at how one computes the slopes of the tangent lines for polar curves. And the bottom line is you can take a polar curve, r as some function of theta, and turn it into a parametric curve with parameter theta as opposed to calling it parameter t. And when you do that, you can use that same formula that we used back when we looked at parametric equations. So, and here's the way you do it. Suppose you have a curve, r is cosine theta, right? Then to put it in parametric form, all you have to recall is what? That x is r cosine theta, and y is r sine theta. But if I'm on the curve r equals cosine theta, then x, which is r cosine theta, is just cosine theta times cosine theta, or cosine squared theta. Y, which is r sine theta, is just, well, r is cosine theta times sine theta, and so you get that. That gives us actually then, see, a set of parametric equations. X is cosine squared theta, y is cosine theta sine theta, and again, theta is my parameter as opposed to previously we had t as a parameter. All right, so if you will recall how one computes dy dx, that's the slope of the tangent line. When I have a parametric equation, it simply is what? Dy d theta over dx d theta. Previously it was dy dt divided by dx dt. So in this case, the example that we're doing, y is cosine theta sine theta, so it's going to be d by d theta of cosine theta sine theta divided by d by d theta of cosine squared theta. All right, and the point is I use the product rule on the top and the chain rule on the bottom, and what do I get? On top, I get what? The first, cosine theta times the derivative of the second, cosine theta, and the derivative of the first minus sine theta times the second, sine theta. And downstairs, what? The chain rule says what? It's twice cosine theta times the derivative of the inside, which is minus theta. Clean things up. What do I get? In this case, dy dx is cosine squared theta minus sine squared theta over minus 2 cosine theta sine theta. The point being now that if you want to figure out the slope of the tangent line for any value theta, you just pick your theta, plug it in, and that gives you dy dx, which is slope of the tangent line. That's the way you figure dy dx for polar curves. You just change them into parametric curves and then use the formula you used at the beginning of this chapter. That's all I'm going to talk about today. Bye.